take notes a little bit differently. I've recorded this lecture. I'm at home sick with a kid today, so I don't want us to skip a beat, me being gone later this week, so we're just going to go ahead and take notes. So this is picking up where we left off, crossing the cell membrane. So I said yesterday that polar molecules and ions, with both of them are charged molecules, cannot go through the cell membrane very easily because of those nonpolar tails in the phospholipids. So in order for polar molecules and ions to go across the cell membrane, they have to go through a transport protein. Now I'm going to just talk through these and read. If you need to pause it to actually type it down or write it down, that's fine, but I'm just going to keep on going. So when they cross through the cell membrane, this is through diffusion still, so it's going from an area of high concentration to an area of low concentration. Ions such as sodium, potassium, calcium, and chloride are important to cellular functions. So they have to be able to cross the cell membrane, but they cannot go just straight through. So they use ion channels. And an ion channel is a pore, like what you think of a pore on your face. It's a hole in the cell membrane that ions can go through. So some of these ion channels are always open, and some have a gate, kind of like a gated community. The ones that are open, there's no gate. They go through when there's high concentration to low concentration. Nothing different, just diffusion. It's just not straight through the cell membrane. It has to take like a certain doorway to actually go through. But some that have gates, sometimes the gates are open, sometimes the gates are closed, depending on the situation. When muscles contract, they need a lot of calcium. So, just for example, when you're working out, maybe something triggers those gated channels to be open. So, as much calcium that is needed can be gotten into the cells for proper function. So, they can be open or closed to respond to certain stimuli. Okay, so here is a picture of these ion channels. So, you've got your normal cell membrane right here with the phospholipid bilayer, the polar head, and the nonpolar tail in the center. This is a gated sodium ion channel. This is allowing sodium to come through the cell membrane. Sodium cannot go straight through the cell membrane, so it goes through the ion channel. From an area of high concentration, you see a lot of sodium up here, to an area of low concentration. So there it is, ion channel. It's just like a doorway or a special area that it can go through. Some of those have a gate, like right here. It can open and shut depending on if it is needed at that time. So when things cross the cell membrane, it creates an electrical charge. At the rate at which molecules will cross the cell membrane depend on that concentration gradient. So since those molecules have a charge, like sodium, if you see it down here, sodium had that charge. Depending on how things cross the membrane will depend if there's a charge. And the nervous system, it's all about an electrical charge. So that's actually quite important to how our nervous system functions. Typically, inside of the cell happens to be more negative compared to the outside of the cell. So you want to keep that balance. This allows for more positive cells to move easier, or more positive ions, to move easier into the cell. As I just said, important for nerve cells. Facilitated diffusion. I talked a little bit about simple diffusion. Simple diffusion is going from an area of high concentration to low concentration straight through that cell membrane. When it is facilitated diffusion, it's still going from high concentration to low concentration, but we're adding carrier proteins. That's all it is. Still is going from high concentration to low concentration, but now we have carrier proteins. This is the protein that helps that substance cross the cell membrane. Instead of if we go back up here, these ion channels, which is just a hole, this facilitated diffusion, which is a carrier protein that's different. It grabs the molecule, holds onto it, and shoves it down into the side of the cell. It actually grabs onto it, carries it through, and pushes it inside. So, we've got a couple different things going on. Just to recap, you have simple diffusion, where something goes from here straight through the cell membrane. Simple diffusion, area of high concentration to low concentration. You also have diffusion, but it can't go through the cell membrane. It has to go through an ion channel. That also goes from an area of high concentration to low concentration, just not through the cell membrane, through a channel. Then there are carrier proteins that also help with that. It's not just a straight shot. It has to be grabbed and held and carried and pushed into the inside, but it's still, if you look at this picture, high concentration to low concentration. So it's all still diffusion.